Good morning. It's July 18th, and this is your daily brief in science. Here's everything you need to know. Recent research indicates that middle-aged individuals with heart disease and diabetes, especially those who experience strokes or mental health issues, face the highest risk of developing dementia. Sana Suri, an associate professor at Oxford, emphasizes the importance of understanding how the timing and combination of these health conditions influence dementia risk. She highlights the need for future studies that include diverse populations to better understand these connections. Another study suggests that infections such as chlamydia pneumonia and SARS-CoV-2 might contribute to dementia by increasing inflammation in the brain. Experts recommend maintaining a healthy lifestyle to lower dementia risk, including regular exercise, limiting alcohol intake, avoiding smoking, staying socially engaged, managing chronic conditions, and protecting eyesight and hearing. A large-scale analysis of data from 282,712 UK Biobank participants examined 46 chronic health conditions to identify critical periods for dementia risk. The study, published in Brain Communications, underscores the importance of understanding health patterns over time. This research aims to inform more effective prevention strategies by focusing on how health conditions develop and interact throughout life. A new study from Cedars-Sinai, published in JAMA Oncology, shows that COVID-19 vaccine boosters significantly reduce hospitalization and ICU admissions among cancer patients. Despite this evidence, vaccination rates remain low in this group, with only 38% receiving the bivalent booster and 69% receiving the monovalent booster. The research involved over 72,800 cancer patients undergoing chemotherapy or immunotherapy, with 69% having received a monovalent booster by January 2022. The findings highlight the ongoing need for improved vaccination outreach, especially as SARS-CoV-2 continues to circulate endemically. The study was conducted by Kaiser Permanente Northern California and funded by organizations including the NCY Serological Sciences Network. Dr. Robert Figlin noted that this research adds important knowledge about vaccine effectiveness in high-risk groups and that further studies are planned to evaluate vaccines in other immunocompromised populations. Cedars-Sinai is also preparing to publish related findings on patients with autoimmune diseases and organ transplants. The Feinstein Institutes for Medical Research continues to contribute to COVID-19 and cancer research efforts. The study led by Dr. Jacek Skarbinski emphasizes the importance of vaccination, showing a 50% reduction in COVID-19 hospitalization risk for vaccinated cancer patients. Additionally, the pandemic caused a 6% decrease in breast cancer imaging for early-stage patients, but there was no significant impact on recurrence rates. Researchers at Drexel University have developed a new building material that incorporates a vascular network within cement, inspired by the temperature regulation mechanisms of animal ears. This design aims to improve energy efficiency in buildings by better managing heat transfer. The material uses phase-change substances like paraffin, which absorb and release thermal energy during their state changes, helping to regulate surface temperatures of walls, floors, and ceilings. The embedded vascular network increases the surface area, which enhances thermal performance. Studies show that larger vascular surfaces slow temperature changes to about 1 to 1.25 degrees Celsius per hour. The research team created various cement samples with different vascular channel patterns and found that a diamond-shaped grid provided the best balance of thermal regulation and structural integrity. Led by Dr. Amir Farnham, the study includes contributions from multiple scientists and demonstrates promising results for energy-efficient building design. Published in the Journal of Building Engineering, the research addresses the fact that buildings account for nearly 40% of global energy consumption and lose about 63% of that energy through surfaces. The innovation tackles heat loss, as about half of a building's energy is used for temperature maintenance, by slowing the rate of heating and cooling. Future research will test different phase-change materials and vascular configurations in larger samples to improve durability and scalability. The study confirms that increasing vascular surface area improves thermal performance, mimicking the natural cooling of animal ears. This bio-inspired approach aims to create buildings that are more self-sufficient in temperature regulation, reducing reliance on external energy and lowering greenhouse emissions. Overall, the material can slow surface temperature changes to roughly 1 to 1.25 degrees Celsius per hour, offering a promising step towards smarter, greener buildings. A new breakthrough in cancer monitoring has been announced, utilizing non-invasive microsensing technology to observe cancer cell dynamics in real time. On July 17, 2025, a study published in Science Advances detailed how Sensome, in collaboration with École Polytechnique and CNRS, developed this innovative method. The technology combines microelectrode arrays with electrical impedance spectroscopy, or EIS, and uses predictive algorithms to deliver faster, noise-resistant results. It has been tested on both normal and cancerous breast epithelial cells, with findings closely matching microscopy observations. This marks the first time EIS has been used for quantitative, real-time monitoring of cell movement and changes over time. The method can track variations in cell density and type without the limitations of traditional microscopy, which can damage cells and restrict optical access. Abdul Barakat from CNRS explained that this approach could replace microscopy, addressing issues like cytotoxicity and optical constraints. Franz Bozak, CEO of Sensome, noted that this technology offers new insights into tumor growth, cell behavior, and differentiation, potentially improving cancer diagnosis and treatment. The system allows for analysis of tissue characteristics surrounding the sensor, predicting how cancer cells evolve and differentiate. This collaborative research focuses on breast epithelial cells and aims to advance long-term, minimally disruptive cancer monitoring. Overall, this development could significantly impact how cancer progression is studied and managed in the future. Recent advances in protein science are revealing that about half of human proteins are intrinsically disordered, lacking fixed structures. Historically, structural biologists often ignored or discarded data on these proteins because they didn't fit traditional models. Now, this perspective is changing as researchers recognize the importance of disordered proteins in biological processes. These proteins are a major component of eukaryotic proteomes, with estimates suggesting over 50% are disordered. A team at the University of Washington, led by the group that developed a library of modular protein parts, has created custom proteins that can target specific amino acid sequences in these shape-shifting proteins. Under the guidance of Nobel laureate David Baker, they used artificial intelligence techniques to transform disordered proteins from undruggable targets into viable options for drug development. Their AI-driven approach successfully designed proteins that bind to disordered proteins, with laboratory tests showing a 91% success rate, binding to 39 of 43 targets. These targets include proteins involved in pain signaling and those linked to dissolving protein clumps associated with type 2 diabetes. The research demonstrates the potential to develop new treatments for complex diseases involving disordered proteins. Findings are published in the journal Science and as a preprint, with open-source software available for further research. Co-lead author Kejia Wu highlighted the creative strategies used to address the challenges posed by these proteins, noting their fluidity offers new opportunities for targeting. This work signifies a major shift in understanding protein function, emphasizing that structure is not the only factor determining a protein's role in biology. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.